about the database design. This will be the last chapter. Then after we complete it, we will continue for the advanced design algorithm that mostly focus on the data structure and the indexing and some other techniques that are used for the DBMS system. I don't think you complete the SQL practice in your exercise lab. We will continue. As I announced in the Canvas message, I'm not going to have the midterm exam. Instead, we will have more quiz in the classroom, and then you can focus on your project and the other activity. Then we will have the final exam that will cover all the chapters that we learned in the classroom. Today we are going to talk about the database programming. So this is the information. From the information we did like the conceptual modeling. In the first step is the conceptual modeling or the high-level modeling. Yeah. So we use the ER modeling technique. This is not only for the database design, it can be used for any other software or even in our real life. Then we convert this ER diagram to the relational schema diagram. Okay, the relational model. So this is the database model. Okay, so we are focusing on the specific database model. So that consists of the relation, which is a table, and the referential integrity, which is the foreign key, and so on. And using using SQL language that we have discussed the last week, we can create a database. To build a database, we need the software, definitely. Okay? The problem solving in computer science need the software. Okay? So for example, the Java programming, we need the Java software. It's a program language. So to use the hardware resource, we need the operating system. Operating system is the software. Anytime to solve the problem using the computer, we need the software. That is the DBMS in the database design in this class. So for the database management system, we are going to use the relational database management system that follow the relational model. Okay, so relational model database management system is our software to create the database. At that time, we can use the SQL. There are two parts of the SQL. One is the data definition language, and another one is data manipulation language. Then finally, you create. So in the exercise lab, you probably create your first table using create table command. Okay, so you have data. Finally, in terms of the building house, you just build a small house in your property. Then the next thing is that all? No, the main purpose of the database. What is the main purpose of the using database in computer science, in computer application, in computer science problem? What is the main purpose of using database? Because we have very large data. Okay? So if we have the small amount of data, like the 1 megabyte or just 1 to 3, we don't have to use the relational database model, or we don't have to use the hierarchical database model. We can just use memory-based approach, which means that in your program, you can just define the customer, the string, or customer vector in your Java program, or you can define your own class. So that's it. Where such a data are stored, it's a memory, okay, in your program. Okay, that is another approach. However, since we have the very large data, so we need to separate the data structure, that is the database model and database management system. Okay, so what is our goal? We want to use this one from where? Our application, our program, okay, our software application program, such as web server or the customer management package software. Any software, any application, we want to use such a database as a source of your very large data. So how can we do that? So using SQL, no. SQL is only the language. SQL is the language only for what? Database query. As you can see, it's a structured query language. This database language is only for retrieve the data from your database, relational database especially. So you cannot use the SQL for general purpose, like the C program, C++ program, Java program. No, you cannot use it. So you need another program language like the C, C++, or Java, .NET, any application that you have been using in your computer or your system, okay? Plus, to access such a database, we need to use the SQL. So that is actually the main problem, okay? So we need to consider another language that is the main language, okay? Sometimes it's called the host language for application logic or some graphical user interface, anything. But from your host language to manage the data, especially very large data, when you have the very large and complex data, we need to access the database. Not all application programs need such a database. Think about the laptop. On your laptop, are you using database system? No, not many people, not many users are using the database system. Only your app. Think about the Microsoft Word. So in your Microsoft Word, do you access the database? No. You can save the file information as a file. Okay, abc.doc file, docx file. However, when you need to access this one from your host language, you should be able to access the relational database management system. Okay, using what? Only SQL. SQL is the only way. This is the only way to be able to access the data in our database system. So we need to consider host language plus the SQL. That is called database programming. So we will see how can we do the database programming. So the most important part of the database programming is the connection. Just to understand the mechanism, how it works. Okay, syntax is not, you already learn host language. You learn the Java language, you learn the .NET, you learn the C, C++. We are not going to learn any other thing. Just based on your experience. SQL, we have learned last class, right? How to use the select, how to use the create table, how to insert the data. So the next thing, the main part of the database programming is how to integrate, how to combine two program languages into one. Unfortunately, they are not very friendly. Okay? Why? Why they are not very friendly? They are not very close. Why? It looks like this is the water and this is the oil. They cannot mix it. Why? Extra point. Just guess why they are not very friendly, why they are not very close.
The difference between their structures actually.
Structures. Their data structures are different. Okay? When we learn the relational database model, what is the definition of the relation? It's a set of your data. It's a group of data. We consider data as a group, okay, which is not considered in our modes of data structure using the host language or your data structure class. Why don't you think about your data structure class? Okay, you learn the linked list or the array or the tree structure or graph structure. They do not consider data as a group. Okay. However, database, because the main reason of using the database is to deal with very large data. So we cannot consider one by one. when we have the trillions of the data. Instead, we consider just no matter how many data are there, we just consider as a group, like the student relation, student table. That consider no matter how many students are stored in the database, it's just a student. That consists of name, ID, major, address. Okay. So because of that, we cannot directly combine the SQL and the host languages. So we will see how to integrate in our application program. That is the main part. If you can understand such a mechanism, then that is very easy and straightforward. Okay. So that is the main part of the database programming. So there are two languages you need to consider. One is the host language, the Java, C, C++, any program language that you are using. So because of that, in your project A, the page 4, you need to select your own program language to integrate with the SQL. SQL is for what? To access the data in our database management system. For example, the Oracle in our project. Okay, all the other part will be in charge of, will be part of this host language. Okay, so our database programming approach is how to integrate, how to combine two different languages, which are not very friendly. The first idea is we have, like for example, the C program, C++, whatever the program language. This is our source code, okay, to access the customer information and display. Then, so we code it. So without database, you can also implement such a system, customer management system. First approach is when you access the data, customer information in the database. At that time, we can plug in the SQL part. So this part is only SQL. And also when you insert the customer information to the database, so insert, whenever you need to access the database, you can plug in, you can embed, you can add the block to access the database. That is called the SQL block. SQL block is embedded into your host program. That is called the embedded approach. First approach is the most popular and most of the system use such an embedded approach. You can plug it. How can you use the program, the embedded program? Anyway, we need to compile. So for example, this is a C program and add a SQL. We will see how to plug it, how to add it later. But suppose that we add the SQL part. What if you compile with the GCC, this program? So let's say this is a ABC.C file. Can you compile this? Can you? This part is not part of C program. So you will see the error message. They cannot understand. So when you embed the SQL into your host programming, first you need to pre-compile. You need to convert this one into host language. Okay? This one, host language. Okay? For example, if we are using C program, this part should be compiled first into C program. Okay? If we are using the C++, this part should be converted to the C++ code first. That is called a pre-compile. Okay? So to differentiate the pure C file and the embedded C file, so we will use the usually PC. So .PC file. So .PC file should be compiled in advance. Then once you pre-compile, this one will be the pure C file. Then using GCC, it can be compiled. So two steps of the compiling. First the pre-compile, then the host language is compiled. So because of that, if you are using the C in Oracle, they say the Pro C. If you are using the C++, it's a Pro C++. Pro, Fortran, pro something. Okay, that is actually the pre-compiler. Who provides such a pre-compiler? DBMS. So Oracle provide their own pre-compiler, Informix provide their own compiler, and the SQL Server provide their own compiler. So this is a pre-compiler. So first pre-compile, then host language command, two-step compiling. Okay, that is the embedded approach. Complicated, right? So you need to compile this one and compile again. Okay, so why don't we make the library for this part? So in SQL, it's not very complicated. We have the connect the database and close the database, close the connection, and select the data, insert the data. So the functionality are limited, right? Even though there are many, so we can standardize such a functionality to access the database. Why don't we make the function one library for database part? Okay, then provide such a functionality to the user. So the main problem of this embedded approach is you need a two-step compile. So if you already provide, already compiled the library or the function, the user doesn't have to pre-compile it. Okay, so that is the library approach or API approach. Example, JDBC. JDBC stands for what? Java Database Connectivity. So JDBC itself is the class file. Okay, you can download the class file from Oracle, from the Sonja, and nowadays is Oracle. You can download from the Informix, the DB2. You can download the JDBC library. It's already compiled, and you can just call the class. Okay, you don't have to compile it again. Instead, in Java, you can import such a library. So that's it. That is the library approach. It's comparing to the embedded approach, it's easier. Okay, but it's not much flexible like this embedded approach because it's a pre-compiled. It's probably limited, but it's easy. So that is the library approach. So these two approaches are solution in terms of the host language. We'd like to use the host language more conveniently with the SQL. The last one is in terms of database. Why don't we implement some addition? What is the main functionality of your host language? It provides very nice graphical user interface. It provides flexibility of the implementation, like the if-then-else conditional statement, and there's a procedural approach, which is not in the SQL. SQL, as you can see, there is no if-then-else. It's a select from where, right? Or you can insert the data. It's a structured language. It's the only language for the relational structure, relational model. So why don't we provide additional, the functionality that are in the host language, like the condition statement, okay? Like the for loop, if-then-else, while loop, and declaration of the variable, okay? Some graphical user interface, but not much graphical user interface. So this functionality will be implemented in the database object that is stored procedure language. It's in the database management system. For example, Oracle is named as a PL/SQL, procedural language for SQL. Okay, the Informix uses procedural statement. I cannot remember what stands for PSN, and each DBMS provides such a stored procedural language in addition to the SQL. Problem: they are not standardized. Each DBMS, each database provides their own syntax of the stored procedure. Okay, but sometimes it's convenient. So we will learn that this one. Mostly this is the function procedure, and trigger. We learn the trigger. So using trigger, we can keep the user define the constraint. Okay. So we will learn that this one later. So 3 approaches are possible for database programming. Embedded approach. Embedded approach means we plug in the SQL block. And the second approach is the library approach. Library, it provides a library or API using API. So we can use the provide the library. Okay, and sometimes it's a component based. The .NET environment or the Microsoft family product, they can provide the component or the DLL file or their so similar, same approach. And last one is in terms of the database, they provide the additional the functionality for the programming, that is a stored procedure. So we will see the one by one. So embedded, we already see this one. So this is an example of the embedded SQL. So you can see that the SQL part is the same as this one. Okay, it's a before pre-compiling. It's a before, and this is the after pre-compiling. So this will be the pure SQL, the syntax. Delete from employee where current. This is we will discuss later. What is the cursor? Okay. Then when you pre-compile, this will be converted to the C, which is not very easy to understand. Okay. This is low-level code provided by the DBMS vendor. So this is an embedded approach. As you can see, each tool differentiate the SQL block from other host languages. We use the EXEC. Okay, EXEC SQL or EXEC begin. If in case it's too long, EXEC end. We will see that such an example. Okay. So this is the old-fashioned approach. So when I learned the database and the database programming, we used such an embedded approach and two-step compiling. But nowadays, most of the DBMS, they provide a library approach, which means the JDBC, or the Microsoft provide the ADO object, so advanced database object. So you can just access the data by calling the object. Okay, so sometimes you may not realize whether you are using database. If you just call the library or component, then that's it. Okay. So this is an example of the API-based. This is OCI example. OCI means so when for example, Oracle developed their own DBMS. Oracle DBMS. Right now, current version is Oracle 12. So 12C. So when they develop their own the DBMS, probably they will use low-level language. So as far as I know, the Oracle, not only Oracle, most of the DBMS use 70 to 80% of C or C++ code. Then the other 20-30% is assembly code directly. So which means there might be, even though we have the select from where close, there might be some low-level C code. So that is the OCI. So sometimes we can use such a OCI, the API directly. Benefit is very fast, 2 or 3 times faster than the SQL. Problem, API, very hard to understand. And even I implement a couple of times OCI the programming, but they do not provide the customized the API document. So I call the customer center. Nobody knows. Even the Oracle, the customer center, they don't know much about such a function like the what is open, parse, and something the name binder. So it's very hard. However, you may see the job description who can do the OCI programming because it's very fast. And so comparing to the SQL, it's 2 or 3 times fast. So sometimes there are job description to find the OCI the program. Also Microsoft API. Some of you guys already did use the Microsoft API in your program language. At the time you may not realize the difficulty of using database. Okay, you can just select from here. That's it. Why? Because they provide the API. Okay, so ODBC is traditionally very popular. It's an open database connectivity. So you can just set up the database connection. At the time, the data source doesn't have to be only the Oracle database or the commercial DBMS. It can be even Microsoft Excel can be data source. So in your programming, you don't have to worry about what is a data source. You can just access through the ODBC component. And nowadays, the advanced database object is the most popular one. We can consider database as the object. So do you remember one of the main problem of the relational database model is it doesn't support object. Okay, it's still relational model, but your programming and the software engineering or the data design is all object oriented. Right? So to address that problem, the Microsoft consider even relational database as an object. However, inside that object, it's still same mechanism. Because of that, sometimes some of the developer they use the built-in or some standalone system that use the Oracle database, but you never ever see the real SQL code because it's hidden, abstract in your object. Okay. In case you need to, one of the student complained the one time to me when the student got a job. So there's an error message like the database, the error code. So try to find where is the problem. Then it called 9 or 10 times the inside, recursive, the object. Finally, there's a database, the code, like the SQL, but which also cannot be customizable. So that is actually the problem. It's easy to implement in terms of the host languages when you are using such API, but very hard for customization. Okay. Java also provide such an API. Okay. So JDBC is one of the examples nowadays. Actually, the Java has been developed in the Sun microsystem, but the Sun is merged to the Oracle. So right now, Java is also part of the Oracle Corporation. Okay. So JDBC provided their driver. Driver means it's a library. It's a Java object library that should be able to connect the database and retrieve the data. Any SQL language you can execute using that object. Okay. So impedance mismatch means such a different thing. So it's a mismatch data structure are different. So in our programming, we need to consider such a. This slide shows the brief summary of the different approaches. The most fastest one is OCI API, okay? Or I don't know any other DBMS system that provides such a low-level API, but Oracle still provides it. It's fast but very hard. And the program language is limited to the C or C++. So ADO.NET is popular. It's very easy to use. It's also support multi-DBMS. You can just set up to the Oracle, this one object, another object to the Informix. So in terms from the user point of view, not much different. You can access the multiple database. Speed is so-so because it's hidden, it's abstract level. So because of that, and also it provides most of the Microsoft family, the program language. JDBC is definitely support the the DBMS. Okay, it's not only for the Oracle, but it's only for the Java program. Okay. So basic step of to access the database from the host language is first you need to connect the database, open. Okay, then use it and close it. This is a basic step. So any program language actually, whether or not it's in the explicitly mentioned connection, but if not, it's already the setup in your object. The ODBC or the ADO.NET, when you configure your system, it's already set up. So first, embedded SQL has the block like this one. So it starts with the exec SQL or exec begin. Okay. Exec SQL begin to differentiate from the host language or and the exec or and the SQL. And in between, we can put the SQL, DML or DDL language. Okay. So this is an example of the C language for the embedded SQL. You can see it's a declare section. There's a declare section. Okay, this part, the variable used for in between host language and database language. So variable character. By the way, I gave you the homework for the difference between variable character and variable character 2, right? Do you remember that? So anyone who can answer? Nobody did the homework? Oh yes.
Richard 2 is going to replace the Richard, just regular Richard. It has some more updates for this old one, for the Richard one.
Any other? Is it different or the same? Just either different or same. Nowadays, it's the same. Okay? But first, variable character varchar was proposed in the standard, SQL 2 standard. So, but it's limited because of due to the data structure itself, it's limited by the 2000 character. Also, the internal data structure are not very efficient. So, only Oracle used the variable character 2 first time, which was not standard. It's only for Oracle. Then it's longer and fast and efficient data structure. Everybody tried to use the variable character 2. Then, right now, variable character 2 is adapted to the standard. So, variable character 2 and variable character are not much different. Later, in future, variable character will be replaced by the variable character 2. So when you are using variable character, that is the same as the variable character 2. So nowadays, even other DBMS, Informix DB2, they are using variable character 2 because it's adapted as the standard. Okay. Anyway, so variable character is the database